Nephio SIG release. Recording started. So hello, this is Stephen from Nephio. So this presentation about Nephio, special interest group release, special interest group. I think on the previous presentations, other presenters from Nephio has talked about that Nephio basically has 3 special interest groups, and release is one of them. So what is actually a SIG release? We are responsible for tools and frameworks for.
We are not seeing the slides anymore.
Are we not?
Yeah, the cover slide was there, and then.
Oh, interesting. Is this moving or no? I can see actually.
No.
Interesting. That has happened before. Well. It is. You can see it now?
Yes.
Okay.
Yeah.
So SIG release is responsible for the tools and frameworks for some developers to get on board, for integration and testing, and then for releasing. So we're managing release, we set up test beds, we are responsible to make sure that a particular set of features are included on a release. We are responsible for all the tools and frameworks that are needed for developments and testings. We are responsible for defining the release process, what the development workflows. We don't decide a schedule in terms of releasing. TSC does that, but we are deciding on the milestone within the schedule from development cycles on when do we cut off a alpha or beta release, when do we actually co-freeze to ensure the code is actually stable before we release it. We are also responsible for making a decisions to see whether or not some features would not be able to make it to a particular release. We are responsible for, as we said, tester setup, CI/CD, and then we are managing the external dependencies packages. And moving forward, we'll be probably post release 1. We'll once more, hopefully more network function vendors are coming on board to Nephio. We are also responsible for certifying those network function vendors as supporting Nephio supported, and then also the SDKs. To ease the network function vendors to jump on board. Oh, wow. Keep on having this problem. Okay. So on release process and management, we have actually here's the links of 2 docs that the community members have actually written about this topic. We basically follow very closely with Kubernetes release process. So our contributor guidelines are basically just a carbon copies of what Kubernetes contributor guidelines are. We have an enhancement proposal process, which is very similar to Kubernetes moving forward. Right now in release 1, we are very finalized in terms of what the design and things are. So that one is not enhancement, this is more like baseline. But then moving forward, our enhancement proposal process would be in place. The release process, as we said, we are modeling very closely with the Kubernetes workload because they're very successful and we can join them. Obviously, we have a much smaller contributor base, but then we do want to cut off the feature freeze, the when do we pull release branches, the bug fixing cycles, and the code freeze. Those are all very much in terms of how Kubernetes actually look into it. Something like a 6 weeks prior to the beta cycles, the code freeze, about 3 or 4 weeks before release tracking, and then at least 2 weeks of code freeze. Those are pretty much mirrored Kubernetes. And keep in mind that we haven't actually executed the process yet. We're in the midst of actually doing that because we're still developing right now for release 1. But then that's our plan right now, is share with the community. It gets consensus. So that's how we're going to execute. And then we'll obviously also have a cutoff day of removing items from feature list if it's not ready. And the numberings are pretty much like Kubernetes. So, the number would be the major release dot minor release dot patch released. We will very likely, so right now the community consensus is the major release numbers will likely not change too much unless there is a completely revamped custom resource definitions that we're publishing. So if for you guys that are following Kubernetes, Kubernetes is still on major release 1 at this point because much of its CLDs are V1. So unless that the major ones are changing, they're not moving to 2, maybe never, they will never move to 2 maybe. But then the periodic minors are going 3 times a year, every 4 months. For us, the community is saying that we are probably having twice a year releases. And again, our contributor base are much smaller, obviously. And then patch is less of a 1 month cycle, which is what Kubernetes does. We'll release patch when there's a major bug that we need to actually release within the half a year cycle. Our issues are tracked by GitHubs, and we use Prow, just like Kubernetes for our CI/CD. So this is already set. Prow is already set up. We have community members from SIG release that sets up Prow. So now if you create a new component repo for Nephio, we'll set up Prow and then put your unit test into part of the pre-submit. And then obviously developers have to define what the integration test is for interval-based testing. But what are we really releasing in Nephio? So a very quick recap, I guess, or maybe that's the first time because Vim and John hasn't gone on yet. In Nephio, very high level, we have a management cluster. We're introducing a concept of management cluster. It is a Kubernetes cluster that can run on any Kubernetes, any cluster that actually supports Kubernetes, any OS set of nodes that are supporting Kubernetes. So, for example, you can put it on cloud, you can put it on-prem. That management cluster is responsible for taking high-level intents, run it through some major processes and controllers, and it comes up with a set of resources that are supported by Kubernetes. So on this left-hand side, the management cluster is where the administrative and configuration management happening on a management cluster. The Nephio would publish a bunch of packages, and we'll talk about what a package is, in a public catalog repo. So we have things that would be on GitHub. We have things that would be on the controllers, that little oval-shaped or gray oval-shaped thing. I take it as a controller. A controller would be something like a container-based software that would process configurations on one side, or more commonly known as operators that would actually actuate. On the right-hand side, particularly, would be things that would take the custom resource and then actuate that deployment onto the workload clusters. Workload cluster is where you're going to run your network functions, in this case, which mostly etch, if you will. And then the communications mainly is through a deploy repo. So Nephio is a GitOps-based system. So when you once you're processing the entire configurations, we push the configuration into a deploy repo. And the deploy repo, there's something watching the deploy. There's a software module called config that we're watching the deploy repos, and it will take the various different resource definitions of the custom resources stored in the or non-custom resources, actually could be built-in resources from Kubernetes. It will take it from the deploy repo, take the latest one, obviously, and then basically reconciles the system, the workload clusters to match that state. So this is basically the GitOps infrastructure. So these setups are required for you to run Nephio, and so those what we'll be releasing is the installation of those sets, and then per each release we may have a different type, a different version for sure of various different controllers, and some of those controllers are externals. So some of the core components are actually from other open source projects. So we'll have related scripts that will do installations, push everything down to make sure that the management clusters are set up. And then currently for release 1, the workload clusters are manually set up. And then there's API for you to register the cluster with register your workload cluster with management cluster software, and then we'll see that as something that we can manage, and then we'll set it up to basically spin up config sing, install your network function operators based on your functions, and then making sure that config sing reads from the deploy repo with the right permissions. So those scripts will be released. We'll release all the container images, obviously, for all these oval shaped controllers. This is not the numbers; there are a lot of them moving forward. And then mainly, there usually is 2 branches of controllers that we use. We have those that are more official Nephios, where they are, if you have any production deployments of Nephios, you include them. There will also be sample ones. We have even on management cluster side, we have example controllers. Particularly for the network functions, this is obviously a user's choice of which network functions they want to deploy. And in that case, for those network functions that have support for Nephio, they would release their own operators, or they would release it at the same time as Nephios, or put it in a Nephio code base. This is all a choice for the network function vendor. We'll talk about that later. And then we'll have installations to make sure that those things get deployed correctly. But then those are more or less example ones. This is part of the release, meaning that they support Nephio v1.0, v1.1, or something like that. But those are not like Nephio core operators and controllers. So those container images will be stored in an Nephio Docker registry. And then we'll have obviously release Kubernetes manifest to make sure that you can actually bring that up. And then at the end, we also support, we released a custom resource definitions for every single released, and then put proper versions on all of those. And then so those things we will release as packages, and those packages are stored in a repository on a Git repository. So we usually call them catalog repos. So Nephio will have a public catalog repo that would specify, oh, this set of packages are used for 5G core network functions deployment. This set of packages are being used for 5G RAN network function deployment. This set of packages are being used for generic 5G network deployments that would include both 5G core, 5G RAN, or maybe some other firewalls or load balancer type stuff that you have. And then, so what is a package? A package, we kind of, for now, for release 1 for sure, and in the foreseeable future, our packages are basically what we CAP packages, KPT. KPT is a packaging manager from released by Google. It is open source for a while now, and it's basically view it as a group of YAMLs, sample YAMLs basically, that we have in a various different directories. So a package may have multiple directories. They would have a bunch of different YAML files representing different resources, custom or built-in resources that you're going to deploy into a particular cluster. Central to all of that is you have a metadata file called cap file. Cap file basically gives you a couple of informations. One of them would be a list of cap functions that would be container cap functions that are either loaded publicly into a container registry, or it may be released as part of the, and most of them would, in Nephio specific one, would be released as Nephio in the Nephio registries directly. So cap functions are, so in the cap file, it's links to cap functions. So if within this particular set of YAMLs, so a bunch of YAMLs are basically a bunch of Kubernetes resources. So all that resources are represented as inputs from users. Users put some inputs. As you know, Kubernetes is declarative intent-based infrastructure. So this basically is a set of config inputs that represents a intent of what you want the system to reflect. So we group them. So for example, as we said, deploying the entire 5G core from a particular vendor would be one package. That one package may contain all the templates of how to deploy a free 5GC network functions, all the network functions within the free 5GC, which is about 10 of them. And then the CAP files may contain CAP functions, list of CAP functions that would be executed when you do a CAP, well, when you execute this package. And then another thing that they have, which is actually very important for the management cluster, is a set of conditions for this package. So if you have a package that deploys a UPF, and one of the things that it does is deploy UPF, then in UPF would require, say, 3 external IP addresses for the N2, N3, N4, and N6 interfaces. Then one of the conditions would be, oh, I need IP addresses for 3 interfaces. That's the simple one. And then Nephio would release controllers that would be watching package conditions, and then try to allocate IP addresses into that. So these CAP files would be statically created to see what the conditions are required for this package to be deployed. So when I said it's static, it's actually not really fully static. So the static pieces are the package manager and package release person would be putting the static pieces in place. But then on Nephio, software could actually dynamically add conditions onto the CAP package. So we can put more conditions, are more like gates to ensure that all the conditions are met before this package could be deployed. As far as our released, these packages mainly contains basically, for example, free 5GC UPF is one package. The network functions itself has package that mainly contains network function vendor or open source project specific configurations. Nephio releases CAP packages that are for the community agree upon custom resource definition CLDs that would have packages that reflects on setting those inputs for the CLDs that we agree as a community. So for example, a common UPF deployment CLD would have its own package. And then furthermore, there will be CAP packages that reflects on your destination custom cluster type. So a cluster from OpenShift on a Dell server would be a package, and then on Google Cloud would be a package, on AWS would be a package. So those packages would be released by respective players. They can obviously, as community, they can post it onto Nephio Docker registry. So these are what we'll be releasing. Oh, go ahead, Charles, I guess.
Yeah, thanks, Stephen. Just a quick question about the static and dynamic part of the CAP files configuration. Assuming Kubernetes certain programmatically goes and changes or updates some of the configuration there, does that is the idea that would get written back into what's stored in the Git repos, or is that purely dynamic and not written back?
So our Git repos are for Nephio only. So
yeah.
So the Git repos for deployment. So in this particular case, the most important things are what we write on deployment. So take it on the left-hand side, the management clusters, and the right-hand side, which is the workload clusters. So anything prior to going into the deployment repo, this is still not committed, if you will, to the workload clusters. So in that case, what I'm meant for dynamically adding conditions to a package is when, for example, you have a generic UPF deployment package, and then if you want to deploy that onto an edge platform, let's say some Hyper-V or something, some other things with VMware, for example, and then they have other needs pertaining to, oh, you cannot, we have to get the cluster prepared before you can deploy a UPF deployment package. Then there's controllers in Nephio that basically is written probably specifically for this particular platform type, that would go in and said that, oh, I know what UPF is, but then for you to deploy this UPF, make sure that I set up my top of rack switch correctly, make sure I set up my fabric correctly, make sure I allocated enough VFs for SRIOV, and then those conditions can be dynamically set on the UPF deployment package. So in that case, our system would not basically deploy, meanings that you committed that package with all user inputs all fully resolved, and push it into the deploy repo. So we'll block the writing to the deployment repo until those conditions are met. So we can dynamically add more. So those are not Kubernetes driven at this point. In terms of if there's any config changes to Kubernetes, that depends on how we structure it. So for example, today, the stateful sets, deployments, deployment sets, and daemon sets that are needed by a particular network functions onto the workload clusters is managed fully by the network functions operator. So in this case, the high-level intents are stored on the repo, but then any changes in terms of saying that, oh, I want to change my replica set from 2 to 4 for my particular workload for UPF, for particular part in UPF, then that's actually strictly a vendor decisions. So if vendors structure it in a way such that it would be managed by the operator, then the operator manage it over at the right-hand side without going to the gig repos. So the network function vendors would have the ability to know that I have capacity of 1 gig uplinks and 10 gig downlink. And then right now I'm tracking the conditions and I'm tracking the current metrics, and then realize that I don't have enough CPU resources to do it. So I need to create another pod. I scale out instead of scale up. I have to create another particular pod within your UPF. That could be reconciled by the operators, and that actually is what we expect to do right now. I think the next meeting after lunch, Vim from SIG2 will be talking about this, the shift left versus shift right model. So at this point, for release 1, the sample network functions that we use is FreeFlyGC, and then for that operators, we have all the deployments, objects, and things to be fully managed by the network functions operator at this point. So hopefully that answers the question.
Yeah, that helps a lot. Thanks.
Okay. So those are the things we're going to release, and then we'll test it against a pure software-based platform at this point. So in the very beginning of the project, we worked with Linux Foundation Edge, and then we did kind of loan borrow some of the test setups and play around with it. And as our one goes, so about 4 months ago, there was a ONE summit, the Open Network and Edge summit, where Nephio has a Nephio date, and then the community actually get together. This test setup, by the way, was actually built by, there's no Google people actually involved, so that we were very pleased to see that there are about 6 contributors from 5 different companies that work on this test setup for the ONE summit, and we love what it is. So we will take it as our CI, as our sandbox, and as our probably target on our integration test platform. So what is it? The test setup we have is it's very simple. So this is actually single VM is what we have today, but it could be done as a single Docker. So there's a contributor in the community that is already pushing this into a single Docker. So you can run that on your laptop if you can. So what it does is this test setup through Ansible scripts, we dynamically set up 4 clusters, kind clusters. So this little things that you see here is kind cluster. 4 kind clusters on a particular virtual machines. And obviously, so kind cluster, for those who don't know, the kind cluster Kubernetes nodes are basically Docker containers. So we're creating one management ones and the regional ones, and then two edge cluster ones, and then also creating the repositories. So you can run that with, obviously sit on the bridge, and then we have a network simulators underneath. So this is, today you can grab it from a Nephio repos and then play around with this. This is actually already working. And then they are wired in the same way. So the networking of that is, when you deploy, we'll be creating different N2, N3, N4, N6 interfaces for UPF. And then those are secondary interfaces. So Nephio will take care of all of those. And then also for this particular deployment, Nephio will take care of making sure that the WAN simulations will be connecting those pieces together based on the requirements of the network functions. And for release 1, what we project to do beyond what we have is we'll be creating a core cluster also to deploy AMF and all the other NRF and all the other network functions if they require to run things, because one of our goal is to run a 5G call across this setup with Nephio created network functions, and also the network wiring of all these different clusters onto the system. So you can put that onto cloud. You can post that onto hopefully your own laptop. It is a little more loaded by the time we have 5 different clusters. There's some requirements. I think you need at least 8 vCPUs to run this. And then there are external dependencies. I mean, time is a little tight, so I'll let you guys just see that offline. We have dependencies on Kubernetes, obviously, and then porch fixing. And then for our one, we have we use FreeFiGC as our sample network functions. Moving forward, we do want to onboard more network function vendors. This is definitely going to be one of our main focus, to make sure that it's easy for network function vendors to jump on board. We will have a certification program to allow network function vendors to test their own network functions using their fields on their own test bed, and then once they pass those tests and submit the test results, we'll give them a rubber stamp saying that they're Nephio certified. And then a bunch of tools that some of them we already built, some of them we're about to build to get network function vendors on board. We're talking about using something that can convert a Yang models files, and which is YAML, and Helm charts into CLDs, and then put them into cat package formats. And then we'll create this skeleton of controllers to actually work with those. We'll publish a bunch of reusable libraries to let network function vendors to easily write operators. This is something under discussions. We may build meta operators to set up the front end to process our CLDs, so that will be a lot easier for network function vendors to only write something like a plugin of whatever language, because we'll probably communicate with them using just gRPC. And then those will be easier, hopefully, to get network functions vendors on board. And then we have entry points for network function vendors to go to, obviously, operators and some other plugins that you can have on the workload cluster side. But even for management cluster side, we currently have well-defined entry points for you to load a vendor-specific controllers onto the management cluster. And then we'll take care of loading, spinning up that management, your controllers on management cluster, as well as putting your operators onto the workload clusters. So this is definitely going to be a focus moving forward. We do want to see more network function vendors jumping on board, and then we'll be building those SDKs and all these other tools to make sure that network function vendors can jump on board. So Nephio is a relatively new project. We would definitely love to see you join us, and then be either give us opinions and suggestions of how we improve, or actually just contributing will be great. So these are some of the links that I understand if I convert that into PDF, you're not going to be able to link to all of that. So I'll put that into your, so these are all physical links.
It should, if it's in PDF, the link should continue to work.
Still we go. Okay, that'll be great. Yeah, so this list are links to how you join the mailing list. Welcome to join. It'll be great to see more community members coming on board. We're looking forward for that, and thank you.
Thank you, Stephen.
Yeah.
Thank you, Tina. We are at the top of the hour. So I think that we are going to pause here for the scheduled break. Sessions will resume in 30 minutes. with a discussion on selected technical topics.
Yeah, any questions, you can find us at the Slack.
Yeah, please post questions on Slack channels or